We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Today we gonna discuss about trigonometric labeling. The trigonometric labeling comes under the subject of surveying, which is a branch of civil engineering. So first question comes in your mind is, what is trigonometric labeling? So trigonometric labeling is made of 2 words. One is trigonometry, second one is labeling. Now, what is labeling? So, labeling basically deals with the measurement of height or elevation. Trigonometry. As we know, it is the branch of maths which deals with the relationship between side lengths and angles of triangle. And for your reference, you can see in the image there is one triangle, actually it's a right angle which has 3 different sides and angle. One is adjacent side, second one is opposite side, and third one is hypotenuse. So why it is important to study trigonometric labeling? If I ask you to determine the height of the building, or you will say, oh, no, not this one, I'm not talking about it. This one. Yes, what you will say? So, trigonometric labeling helps you to determine the height of the building. How is it possible? I'll show you then. As you can see in the image, there is a building of which we need to determine the height. And I just put my instrument at a little distance from it. Suppose I put the instrument, which is actually a theodolite, at a distance d from the building, and it's making an angle theta to the top of the building. Now, how does trigonometry help us to determine the height of the building? Let's do first revision of trigonometry. In trigonometry, as we know, suppose this is a triangle where theta is the angle, the side exactly opposite to theta is opposite side, the side near to the theta is adjacent side, and hypotenuse. And we also know the 3 different formulas of trigonometry, which is first one, tan theta is equal to opposite side upon adjacent side. Second, sin theta is equal to opposite side upon hypotenuse. And third, cos theta is equal to adjacent side upon hypotenuse. In trigonometry, there are three formulas. One is of sine, second one is of cos, and third one is of tan. But in trigonometric leveling, to determine the height of the building, we just need only one formula, which is tan theta is equal to opposite side upon adjacent side. So, as you can see in the image, there is one building. Suppose its height is h, and d is the distance between the instrument and the building, and theta is the angle of elevation to the top of the building. Now, if we apply the formula of tan theta, where tan theta is equal to opposite side upon adjacent side, in this situation, then it gives us tan theta is equal to h by d. So we got the equation here, tan theta is equal to h upon d. So we got the equation here, tan theta is equal to h by d, but we need the value of height, which is h. So rearranging the equation, we will get h is equal to d into tan theta. So this equation tells us that if we know the value of horizontal distance d and the angle theta, then we can determine the height h of the building by using h is equal to d into tan theta. Now for example, I want to determine the height of the building, and I just put my instrument at a distance d is equal to 30 meter away from the building, and the instrument makes 30-degree angle to the top of the building. So the equation h is equal to d tan theta is equal to 30 multiply by tan 30 degree is equal to 17.3205. This is the height of the building. So by using this equation, we can determine the height. But in actual condition, the instrument is actually a little above than the base of the building. So in this situation, the height which we get from the equation is from the height of the instrument. So in this situation, we need to first determine the height of instrument, then we can determine the height of the building by applying the equation. The total height, the actual height, total height or actual height of the building is equal to height of the instrument plus the height which we got from the equation d into tan theta. So for the example, we got the height h is equal to 17.3205 meter from the equation of h is equal to d into tan theta. Suppose the instrument is around 1 meter above the base of the building, means height of the instrument is equal to 1 meter, then the total height or actual height of the building is equal to height of instrument plus d into tan theta is equal to 1 plus 17.3205. That means actual height or total height of the building is 18.3205 meters if we neglect the benchmark.